Today, we're diving into a completely radical new theory of the universe. It's one that suggests everything we thought we knew, from the biggest cosmic structures right down to the quantum realm, is all just part of one single, rhythmic, five-dimensional heartbeat.
So, to even begin to grasp this new idea, we have to start with a really uncomfortable question. What if our fundamental model of reality isn't just a little bit incomplete? What if it's completely wrong?
You know, for the longest time, cosmology had this magnificent story, this beautiful cathedral of mathematics and theory. But lately, that cathedral has started to show some really serious cracks.
For decades, the Standard Model was the gold standard. It was built on these solid assumptions of cold dark matter and a static dark energy, and it reigned supreme. But as our telescopes got more and more powerful, we started seeing things that they just didn't fit. The walls of our cosmic cathedral are definitely starting to groan.
And two massive cracks have just blown open. First, new data from the Dark Energy Spectroscopic Instrument, or DESI, is showing that dark energy isn't some constant force pushing everything apart. No, it looks like it's actually changing over time. And second, the James Webb Space Telescope found these huge, fully formed galaxies way back in the early universe. Galaxies that, according to our models, should not have had nearly enough time to form. They just shouldn't be there.
Look, these aren't minor issues we can just patch up with a few small adjustments. The foundational pillars of our entire understanding of the cosmos are being shaken. It's time for a whole new model.
And that new model is, well, it's something else entirely. It's a complete pivot away from a simple one-way expansion to a complex rhythmic vibration.
This slide just lays out the paradigm shift perfectly. On the left, you've got the old way of thinking. Our 3D universe is like a balloon, just expanding forever. But on the right, you see the new vision. Our 4D universe is actually an elastic membrane. They call it a brane, and it's vibrating inside a larger 5D space. So in this new picture, our universe isn't just expanding, it's oscillating, it's breathing.
And here is the absolute heart of the idea. All these mysteries we've been chasing, dark matter, this weird dynamic dark energy, they aren't exotic stuff you could ever hope to put in a bottle. Instead, they are the geometric effects, the ripples and the stretches of our 4D brain moving and vibrating through that fifth dimension. They are simply artifacts of a single underlying physical process.
So, what's actually driving this cosmic vibration? Well, the theory proposes something it calls a stick-slip motor, and it's actually pretty easy to picture. Think of a rubber band being stretched. The stick phase is the slow, steady pull from the cosmic web, stretching our universe out into that fifth dimension. And the slip? That's a sudden, violent release of all that tension, a snapback triggered by a whole network of primordial black holes. And this entire cycle just repeats over and over every 2 billion years, creating a cosmic heartbeat.
Okay, a beautiful theory is one thing, right? But does it actually hold up? Does it align with what we can actually observe in the real world? Let's take a look at the 4 key pillars of evidence that could support this wild new cosmic model. You see, a truly unified theory has to work everywhere, at every single scale. So to put this theory to the test, we're going to go on a journey through 4 totally different scales of existence. We'll start at the very edge of the observable universe, then we'll look at the afterglow of the Big Bang, then we'll zoom into our own galactic neighborhood, and finally, we'll end up in a lab right here on Earth.
Pillar number 1, the cosmic dawn. Now, the Standard Model expects that the first galaxies formed in a pretty smooth, gradual process. But this new Brane theory, it predicts something absolutely wild. As our universe breathes in and out of the fifth dimension, the force of gravity itself oscillates. It gets stronger and weaker. And this would have imprinted a massive 2 billion year heartbeat directly onto how all that primordial gas first started clumping together.
And here is the absolute kicker. The theory predicts that this cosmic heartbeat will be detectable by the upcoming Square Kilometre Array telescope as a 5.5 sigma signal. Now, for anyone who doesn't follow physics, a 5 sigma signal is the gold standard. It's the threshold for a history-making discovery. So this isn't just some vague idea. It's a hard, concrete, testable prediction.
Okay, our second pillar of evidence takes us way back to the cosmic microwave background, which is the faint afterglow of the Big Bang. For years, scientists have been totally stumped by this huge, unexplained power deficit in the signal at very large scales. Well, this theory offers a really elegant solution. It says that deficit is just the result of destructive interference that happens as our 4D universe moves through the 5D bulk, basically flattening out the light waves as they travel across the cosmos to reach us.
Now for Pillar 3,
we're going to turn to that amazing recent discovery of a background hum of gravitational waves by the Nanograph project. The conventional wisdom is that this hum is the combined chorus of countless merging supermassive black holes. But this new theory says, that's not what we're hearing. We're actually hearing the echo of the cosmic engine itself.
I love this term the source material uses. It calls this signal the geometric jerk of the cosmic engine. That violent slip phase of the motor doesn't just send out a single shockwave. It's more like a huge bell being struck, creating all these rich, complex, multi-tone sounds. And it's those extra tones, those so-called anharmonic overtones, that perfectly match the strange gravitational wave signals Nanograph is picking up.
And finally, pillar number 4. This brings us from the vastness of the cosmos right down into a tiny lab. There are these quantum experiments called QB-ounce that have found that neutrons just don't behave the way they're supposed to when they get really close to a surface, like a mirror. The theory says this is happening because gravity is literally leaking into the fifth dimension at a very specific threshold. And, once again, it makes another incredibly precise prediction. An upgraded version of the experiment will see a massive 55-fold spike in this weird behavior at exactly 0.2 micrometers.
So after our journey through all 4 scales, from the cosmic to the quantum, what's the final verdict? Well, it looks like we're seeing the first shadows of a completely new reality.
And this slide just brings it all home. On the left, you see 4 major, unsolved observational anomalies at 4 totally different scales. In the middle column, you've got the standard model, which has 0 explanation for any of them. And then on the right, you have the V8.0 Brane predictions, which perfectly and precisely account for each and every one. What used to be these scattered, isolated problems now all fit together in a single, unified framework.
And this right here brilliantly illustrates the ultimate takeaway. That weird signal from the cosmic dawn, the power deficit in the CMB, that strange gravitational wave hum, the quantum anomaly in the lab, they are not 4 different problems that need 4 different fixes. No, they are 4 different shadows cast in 4 different ways by the exact same 5-dimensional object, our breathing universe.
Now, this isn't just some philosophical shift in our thinking. If this theory turns out to be right, it could unlock a whole new era of technological innovation that sounds like it's straight out of science fiction.
Because think about it, understanding how gravity really operates beyond our standard 4 dimensions isn't just about cosmology. It literally provides a tangible engineering blueprint. It could show us how to bypass the single biggest roadblock in quantum computing, a problem called decoherence, by accessing quantum states directly through the 5th dimension. This could be the key to building the ultimate machine.
And that leaves us with one final, profound question. For all of human history, we've basically been passive observers of the cosmos. But if our universe really is a vibrating membrane, could we one day learn how to manipulate that vibration? Could we go from being the audience to being the conductors of our own cosmic symphony?